Hi guys, I am Divyang. You are watching IGCSE on Fingertips, and today we are going to understand bonding in atoms. Let's get started. So, in atoms, right, the atoms can combine. Why do atoms combine? Because they want to gain stability. How do they gain stability? By making their outermost shell have 8 electrons. In case of hydrogen and helium, it is okay if they have 2 electrons in the outermost shell. And what do they do? To go from whatever number of electrons they have to the stable shell, they gain, lose or share electrons. Depending on the gaining, losing or sharing of electrons, will have different types of bondings. Right? Now, they may form compounds or elemental molecules. Elemental molecules like oxygen, nitrogen, chlorine, right? That is a diatomic molecule. Each molecule contains 2 atoms, right? So elements may combine. If it is metal, we will see metallic bonding. If it is element, we will see, and if it is element, sorry, and non-metal, we will see different types of bonding. Each of them, if it is forming a compound, it may be between a metal and a non-metal. If it is between metal and a non-metal, it will be ionic bonding. If it is between non-metal and other non-metal, it is generally covalent bonding, right? We will look at structures in this class. We will look at how do they form the molecules, right? And we will look at the fact that what happens when they form these molecules. Now, as I have already told you, that they may gain, lose or share electrons. So if they gain or lose electrons, ionic compounds are made, right? Now atom is ideally neutral. This neutral atom, if gains or loses an electron, forms an ion, right? Let's take an example of sodium. Here sodium has 11 protons and 11 electrons. But if you look at the ion of sodium, it has 11 protons. It is not losing any protons, but it is losing one electron. So there is one proton more than the number of electrons. When this happens, sodium has a positive charge, right? We know that the relative charge of one proton is +1. Therefore, if it has one proton greater than the number of electrons, it will have a positive charge. Looking at chlorine, what will happen? Chlorine is forming an anion. Okay. Now it is gaining electron. It is gaining electron and forming a negatively charged ion. Negatively charged ions are known as anion. Positively charged ions are known as cations, right? Generally, cations are formed by metals, anions are formed by non-metals. Now, if you want to remember it, cat has T, right? That T looks like a plus. So you can remember it like this and not get confused. Now, ions are oppositely charged whenever this exchange of electron takes place, right? So if chlorine wants to get an electron, it will have to take that electron from sodium, right? Whenever sodium wants to give an electron, it needs to have another atom that is ready to take up this electron. Therefore, sodium loses an electron, it gives this electron to chlorine, right? This is a dot and cross diagram. In my diagram, I have shown the electron of sodium with a red dot, right? What you should do, you should draw a cross on one of them, dots on one of them. See, look at this diagram. What happens here? They have shown the dots, electrons are from chlorine, but this cross comes from somewhere else. So we must always denote this. There are marks for us to denote this, that the extra electron is coming from somewhere else, right? So sodium gives one electron to chlorine, and then sodium forms a positively charged ion, chlorine forms a negatively charged ion. These ions are oppositely charged, and oppositely charged ions attract each other. This electrostatic force is a very strong force, right? But the compound has no overall charge. Now let's look at what happens when 1 mole of sodium reacts with 1 mole of chlorine, right? Or rather, we will say, because not just one atom generally react, a lot of atoms are going to react, and they are going to form alternating positive and negative charges. All the sodium will form positive charges, all the chlorine will form the negative charges. Now what will happen we will see a lattice formation. What is lattice? Lattice is when there is a repeated arrangement of alternating atoms, right? Here the lattice is formed by positive and negative charges. Now lattice is a giant structure. Giant structure as in, you can look at it, you can grind sodium chloride, right? It has small crystals. That crystal is one lattice. Okay, it has a lot of positive and negative ions, so it is a giant structure, also sometimes known as macromolecular structure. Now what is there? There is positively charged sodium ion, negatively charged chloride ion. See, sodium has two shells after it forms ions. Chlorine has three shells after it forms ions. So chloride ion will look larger than sodium ion. Now if you look at, let's say this negatively charged ion, it is surrounded by positively charged ion. Pick any positively charged ion, it is surrounded by negatively charged ion. This will keep on happening repeatedly, and therefore sodium chloride has high melting and boiling point. All the ions are attracted to each other very strongly, right? Let's look at other examples of bonding. So magnesium can bond with oxygen. Again, in this diagram they have shown dots. What you should do is, instead of this, you should write crosses. So these electrons go over here, and therefore oxygen will have 2 electrons from magnesium. This will be shown as 2 minus, this will be shown as 2 plus, right? This will tell us that they are forming ions by the transfer of electrons. Because these two are forming ions, they are oppositely charged, and they will attract each other and form MgO. Now we will also see how to write the formula of an ionic compound, because I must know that what will be the formula. In exam they will test and they will ask questions that what will be the formula, and when you are starting with the syllabus, it becomes a little bit of challenge to deduce what the formula will be. Once we understand this, we will look at the formation of formula, how to write down the formula. Now see, in sodium and chlorine there was transfer of one electron. Now magnesium has an electronic configuration of 282. It has 2 electrons in the outermost shell, therefore it transfers these two to oxygen. Oxygen wants 2 electrons because there are 6 electrons in its outermost shell. The atomic number of oxygen is 8. The configuration is 2, 8. Therefore, it requires 2 electrons to complete the outermost shell with 8 electrons. So this is a 1 to 1 ratio, right? One magnesium can give both of its electron to one oxygen. But something else happens in chlorine. Chlorine requires just 1 electron, right? Let's do this again. So chlorine requires only 1 electrons, but magnesium, if it wants to gain stability, it requires to give off 2 electrons. So what will magnesium do? It will bond with 2 chlorine at the same time. So magnesium does form 2 plus. It gives both the chlorine 1 electron each, and therefore forms MgCl2, right? Because there are 2 chlorines involved, it will form MgCl2. Now let's see. Ions can also be formed from a group of bonded atoms. They are called compound ions. Now thankfully we don't have to look at the Lewis dot and cross structure of these ions, but we do need to remember their charges so that we can form formulas of compounds easily, right? So you have NH4 plus, right? 1 nitrogen, 4 hydrogen, the overall charge is positive. Then you have OH minus, 1 oxygen, 1 hydrogen, the overall charge is minus 1. 1 nitrogen, 3 oxygen, overall charge minus 1. Nitrate ion, carbonate ion, 3 oxygen, 1 carbon, 2 minus charge. Sulfate ion, 1 sulfur, 4 oxygen, 2 minus charge. Sulfite ion, 3 oxygen, 1 sulfur and 2 minus charge. So these are some ions that we need to remember. Now before we start to understand how to write the formula, let us look at the properties of ionic bonds. Now this is the first type of bonding we are looking at, and we have seen that they form lattice. If they form lattice, it is given that they have very strong attractive force. If they have strong attractive force between different particles inside a crystal, then the melting and boiling point are going to be very high. What do we do when we melt and boil things? We have seen in the last chapter that when we boil something, the particles will try to move apart, right? Or when we melt something, the particles are still trying to move apart. How do they move apart? By the energy we give them in the form of heat energy. What is happening? The intermolecular forces are being broken, right? Here, the bond between, let's take an example of magnesium oxide. We have already seen magnesium oxide. So let's take an example of that. We are not breaking the bond between magnesium and oxygen. We are breaking bond between different groups of magnesium and oxygen, right? It will become clearer when we look at covalent compounds, but as of now we will say that because of strong attractive forces, these are solids. They have high melting and boiling point. They are hard, and as the compounds are made of ions, they can conduct electricity when molten or aqueous. When they are molten, what will happen? The ions can move around. Right now we have seen the structure, which was the lattice structure. What did we see? That the ions are fixed in their place. If you dissolve this all ions in water, the ions can move with the charge, right? Sorry, the ions become charge carrier. They can move with current, right? Which is why current can be passed through dilute uh, acids, or current can be passed through water that contains some salts. So these ions become the charge carriers. They are mobile ions. They can move around, right? So if they are aqueous, they can conduct electricity. Now the same thing should happen when they are molten. Again, when they are molten, they are in liquid state. In liquids, the particles can move past each other. So the ions can again become conductors of electricity, and therefore they can conduct electricity, but not when they are solid, only when they are molten or when they are aqueous, right? Now let's look at formula of ionic compounds. How to deduce the formula of ionic compounds, and you can use this method to even find out the formula of covalent compounds. Now see, I will write magnesium and oxygen, right? What magnesium wants to do? It wants to lose 2 electrons. So it will form a +2 charge. This +2 charge is known as oxidation state of magnesium, right? Oxygen wants to gain 2 electrons, so it will have a -2 charge. This is also known as oxidation state of oxygen. What is the first step? Try to find out the smallest ratio between them. The smallest ratio is 1:1, right? You can ignore the sign when you're making the formula, right? We are trying to balance the charges itself. So when charges are balanced, as we have already seen, that the compounds have 0 charge. So this gives Mg and O, right? Let's look at calcium carbonate. So calcium, it is 20th element. So it has a charge of +2, and carbonate we have just seen has a charge of -2. Again, they can combine in 1:1 ratio, right? Sorry, they can combine in 1:1 ratio, and therefore I can write CaCO3. Let's have a look at zinc. Zinc has a charge of +2. Right now you may not know this, but once you are done with periodic table, once you are done with a lot of other elements, right, we will see transition elements. After that you will be able to judge. There are very few elements for whom you have to remember the oxidation number as it is. So, and even by looking at their position in the periodic table, if it is group 2, it will have a valency of +2. If it is group 6, it will have a valency of -2, right? So with the help of periodic table, you can find out what valency it will have. And then you have NO3. NO3 we just saw has a charge of -1. Now the ratio is 2:1. So what I'll do, I'll multiply this 2 over here, and I'll multiply this 1 over here. So I will write Zn subscript 1 and NO3. We don't write charges, we just write the number NO3 twice, right? This can be written as, we will ignore the 1 as subscript, because the fact that we are writing Zn means there is one atom of Zn in the compound, right? And in ionic compound, as it is, we are writing the ratio of the number of positive and negative charges. In lattice, what happens? There are a lot of positive and negative charges. So we don't count the negative charges, we only count the ratio, right? Let's look at ammonium sulfate. So we just saw NH4 has a charge of plus, SO4 has a charge of 2 minus, right? From here I can write this will be NH4 twice and SO4. I don't need to multiply 1 over there. Now let's look at the next type of bonding. If elements or atoms share electrons, they become covalent bonds. Okay, now covalent bonds can be formed between elemental molecules. Look at hydrogen over here. Hydrogen requires 2 electrons, right? I said that only hydrogen and helium can have 2 electrons and still be stable. So what will hydrogen do? Hydrogen will go to another hydrogen. They both will share one pair of electron. Each hydrogen will give 1 electron towards the sharing and it becomes a pair, right? So what can I write? In simplification, I can write this is hydrogen dash hydrogen, hydrogen bonded to another hydrogen. The same thing happens with chlorine. Now see, chlorine also requires 1 electron in the outermost, 1 more electron in the outermost shell, I'm sorry, and will have 8 electrons in its third shell, right? So what will chlorine do? Chlorine will also bond with another chlorine and form a single bonded Cl2, right? Each chlorine is giving just 1 electron for bonding. So it is forming a single covalent bond. Covalent means sharing of valence electrons. Now, what will happen with oxygen? Oxygen has 6 electrons each in the outermost shell. Each of them require 2 more. So both of them will share 2 electrons. So I can write this as oxygen double bond oxygen. Now, if you observe, they have given clear dots and crosses to each oxygen to separate that which electron is coming from where. As it is, electrons don't have their own identity. This is for understanding that how does sharing happen, right? For nitrogen, there is triple bond, right? Nitrogen has, what is the configuration of nitrogen? It has 2, 5 electrons. So both of them require 3 electrons. Now if they require 3 electrons, they must share 3 each, which means that is a triple bond. So if they share 1 electron each, it becomes 1 pair of electron. If it becomes 1 pair of electron, it is single bond. If they share 2 electron each, then it becomes 2 pairs of electrons. If it becomes 2 pairs of electrons, it is double bond. If they share 3 electron each, again 3 electrons, 3 pairs, and then triple bond, right? I hope this is clear. Let's see what else can covalent nature do. Now sharing of 1 electron from each atom, sharing of 1 electron from each atom or 1 pair will form single bond. 2 electrons will form double bond. Now they can also form compounds. Sharing of electrons between atoms of 2 or more elements. So methanol, you look at methanol over here, what is happening? Carbon has 4 electrons in its outermost shell, right? Let's take a brighter color. Okay, carbon has 4 electrons in its outermost shell. If you look here, this is the electron of carbon. This is carbon's electron, this is carbon's electron, and this is also carbon's electron. Now each hydrogen is sharing 1 electron with carbon. So what is this structure? This structure can be written as CH, H and H, and then you have single bond O. Why single bond? Because carbon has given 1 electron, oxygen is also given 1 electron. Now see, in this, because there are 3 types of atoms involved, they have taken dots, crosses and circles, right? Take care whenever you are writing these answers in your exams or in your worksheet, right? Oxygen is then bonded to hydrogen. What is this compound? Methanol. Right now you don't need to learn the names, you only need to know what is the sharing taking place. Then if you look at carbon dioxide, then carbon double bond oxygen, double bond oxygen. See, each carbon has shared one pair of electron with each oxygen, and each oxygen has shared one pair of electron with each carbon. If you look at the structure of ethene, it is C double bond C. Carbons have shared a pair of electrons with each other. I have no idea why this is not happening. Anyway, guys, so we have, okay guys, there was some problem in the system. Now, so with ethene, what is happening? Carbon double bonded to other carbon, each carbon also bonded to hydrogen, right? I know the number of bonds because I can count the number of electrons carbon has given for sharing, right? Let's go to the next thing. What do we need now? We need to understand the properties of covalent bonds. Now, I told you that the attraction will become important when we are looking at covalent bonds. So let's have a look at this. So if there is, let's say, carbon dioxide, right? We've just seen carbon dioxide, and we all know that carbon dioxide is a gas. Now, from the understanding of attractive forces, we need to explain that why does carbon dioxide exist as a gas. Okay, now if you remember, in ionic compounds, all the ions were coming close to each other, the bonds were stronger. Now the double bond of carbon and oxygen is strong, but there is no force of attraction between two molecules. The intermolecular forces are weak. Because intermolecular forces are weak, the melting and boiling point of carbon dioxide is low, right? I'll repeat this again. The attraction between one molecule of carbon and the other, one molecule of carbon dioxide and the other molecule of carbon dioxide is very weak. They don't want to come together, right? They don't have attractive forces. There are no charges involved, because of which they have very low melting and boiling point, right? Then they are generally gases. Covalent compounds that we will come across are generally gases or liquids. Okay, we will see very rarely covalent compounds that are solids. Okay, and they don't have any free charges, so they cannot conduct electricity. But if these covalent bonds are formed repeatedly, they can form large molecules known as giant molecules. Let's find out what are giant molecules. If the sharing is between a lot of atoms, giant covalent structure is formed. See, look at this. This carbon is bonded to 4 other carbon. Then this carbon will be bonded to 1 and 3 more carbon. It will happen for each carbon. We will have a giant structure which has all the strong bonds which are all covalent in nature. All of these strong bonds form a structure known as diamond. If carbon is forming a tetrahedral structure, then it is diamond. Diamond because of its strong bonds, right? There is no need to attract other molecules. The molecule itself is very large. The large molecules of diamond make it very hard. In fact, the hardest substance naturally available. Then there is a similar structure between silicon and oxygen. Now, if you notice, this black dot is a silicon. It is surrounded by 4 oxygen, but each oxygen is surrounded by 2 silicon. So the ratio of silicon and oxygen in this compound is 1:2. For every 1 atom of silicon, there are 2 atoms of oxygen available. So the formula becomes SiO2, and we write it as silicon 4 oxide because the valency of silicon is 4 in this compound. It is forming bonds with 4 other carbon. And if you go and look at your periodic table, you will find that silicon is in fact in the 4th group. So silicon also had a tetrahedral structure like diamond. So it will share properties like diamond. It is not as hard as diamond because it cannot form that large bonds, but it sure has very high melting and boiling point, because of which we will find some uses for both diamond and silicon, right? Other than it being a precious material for diamond. Now here, if you observe, all the atoms are covalently bonded and the bonds are strong in these compounds, right? We have already talked about this. But carbon has some versatile nature. It can form more than one type of compound. Now what did we see there? We saw tetrahedral structure. Here there is hexagonal structure. See, 1, 2, 3, 4, 5 and 6. So there are 6 carbon, and each carbon is surrounded by 3 other carbon. There is a layer, there is a sheet of this hexagonal carbon ring, and then each layer is on top of another layer, which are weak forces, right? This forms graphite. This carbon compound is known as graphite. But this one weak bond gives us a lot of benefits. Let's see. Now see, diamond, it is hardest known natural substance, can cut into other substance. Because it can cut into other substance, we use it as a drilling and cutting tools. Then graphite, it is soft and slippery, but it can conduct electricity because it has one weak bond. This weak bond, the electrons can move between two sheets. So these are the two sheets, right? The electron can move from one end to another between these two sheets. So even graphite has delocalized or mobile electrons. These mobile electrons make it a good conductor of electricity. As a lubricant, because it is soft and slippery, you can use it as a lubricant for engines and locks. Because it conducts electricity, you can use it in electrodes. We will see electrochemistry, in which we will find that we do use graphite electrodes to carry electricity, right? Then silicon oxide, I told you that it shares structure with diamond, so it will have a high melting and boiling point. It is hard, will scratch other substances, so can be used in sandpaper, and has high melting point, so can be used in bricks for lining furnaces. We'll look at blast furnace, where we extract iron from its compound. Now that temperature rises very much, and if we are extracting iron and iron is melting inside it, the structure cannot be of iron. So structure will be of silicon oxide, right? It is a very good material that insulates us from heat, right? Because it has a very high melting and boiling point, on top of which it is also a bad conductor because it does not have free electrons, right? Silicon and diamond, both of them do not have free electrons. Now if we look at metals, metals are a special case. See, if it is a molecular structure like carbon dioxide and water, they have low melting and boiling point. If it is giant ionic, I told you that ionic structures, the lattice is always giant. The sodium chloride and magnesium oxide, both of them have very high melting point compared to the molecular structure. Now we just looked at covalent structure, which is diamond and silicon oxide. See, they also have high melting and boiling point. Now if metals also have high melting and boiling point, iron has a melting point of 1535 degrees Celsius, copper has a melting point of 1083 degrees Celsius as a melting point. Now if they have high melting and boiling point, it must mean that they have a giant molecular structure. They are forming some sort of lattice. So metals have a giant structure. The electrons that the metal have, they can detach from the surface of the atom or from the atom, right? And it can form a lattice structure where there are regularly arranged cations, and these cations are surrounded by electrons. There are so many electrons, it's like keeping like 10, 15, 20 marbles in a glass filled with water. So as water covers all the sides of this marble, in the same way these electrons cover the cations from all these sides, and that is why it is known as sea of electrons. Now cations are positively charged, electrons are negatively charged. There is a very strong force of attraction between these two, which means metals having lattice structure and high force of attraction should have high melting and boiling point. Now it makes sense also that metals have free electrons. This free electrons helps them or makes them have a very good or be a very good conductor of heat and electricity, right? These free mobile electrons, the sea of electrons, help them become very good conductors of heat and electricity. So the properties of metals become very obvious. that the sea of electron makes good conductors of heat and electricity. Strong forces of attraction make them have high melting and boiling point, and the arrangement is forming lattice, right? This lattice can be slided over each other. See, if I apply force over here and here, these lattice will start sliding over each other, which will make them have ductility and malleability. So I can hammer a metal and make it into a thinner sheet. That is malleability. When I am hammering, I am applying forces and I am asking these cations to slide over each other. When I am pulling the metal, right? Let's say there is a metal rod, and if I am pulling this metal rod, the rod will start becoming thinner and thinner. I am drawing it into wire. That is ductility, right? That also happens because these cations can slide over each other, right? In further chemistry, we will see that how this lattice structure can be taken advantage of, and alloys can have better properties than the metals they are made of, right? But before we go to all of that, let us summarize about what type of questions will be asked. So obviously they will ask a lot of questions like, why does sodium chloride have a high melting point and nitrogen dioxide have a low melting point? So you have to write that sodium chloride has ionic bonding and has strong electrostatic forces. Nitrogen dioxide has a covalent bonding and weak intermolecular forces, right? I will attach a worksheet at the description, in the description of this video. I will attach these notes in the description of this video for you to find out and practice these questions. Also, just as a summary, you should remember, and these type of questions are asked, that they will give you melting a list of elements A, B, C, D, or materials A, B, C, D, E, F, G, and they will give you melting points, boiling points. They will give you that can they conduct electricity when they are solid, can they conduct electricity when they are dissolved in water, and then they will ask you which of them are ionic bonds, which of them are metallic bonds, which of them are covalent bonds. How will you identify? There is a very simple set of questions you need to ask yourself. If it has low melting point and low boiling point, if it does not conduct electricity anywhere, it has to be a covalent bond. If it has a high melting point and boiling point and does not conduct electricity, then it has to be a giant covalent structure. But if it has high melting point, high boiling point, does not conduct electricity when solid but conducts electricity when aqueous or molten, then that is a giant ionic structure. But if it has high melting point, high boiling point, conducts electricity when solid, it has to be a metallic bonding. If you remember this much, most probably you will be able to solve all the questions in my worksheet with the help of notes, with the help of your textbook, your knowledge, and some of your hard work.